Hello, this is Mr. Henry, and welcome to lesson 4.2. Today we're going to graph linear equations. In the last lesson, we talked a little bit about linear functions and how they always make straight lines. It's going to be the similar today. The essential question is, how do I graph linear equations in a coordinate plane? Okay, we have two get the goofs. Now these get the goofs come from the last chapter, chapter 3. Try to take each of these equations and solve for y. So you try to get the y by itself. The way we did this in the past is, since this was the variable we were solving for, we would basically go through those 5 steps. There's no parentheses, there's no like terms on either side. I do not have a y on both sides of the equal sign. I do have this thing that's being added or subtracted. So I'd minus 3x on both sides. Get 4y equals negative 3x plus 16. Then divide by 4 here and there. These cancel out. We get y equals a negative 3x divided by 4. We just left that as a fraction because it's easier to graph a fraction, a slope with a fraction, than it is with a ugly thing. So this is just negative 3/4 x, and 16 divided by 4 is a positive 4. So this would be correct, that would be wrong. So actually, let's just get rid of him. Second one. Well, there's our y, so we're going to add 6x to get rid of him, and add 6x on that side. So these cancel out. We get negative 2y equals 6x minus 12. Again, we like having the variable terms before constant terms. Divide both sides by a negative 2, and we'd get y equals 6 divided by negative 2 is a negative 3x, and negative 12 divided by negative 2 is a positive 6. So it actually looks like the thing that was forgot to do here is they forgot to get rid of this negative. They only divided by 2, not negative 2. Okay, so this is kind of combining a bunch of stuff we've done before, but into one type of problem. So first off, equations in two variables. We've seen equations with two variables before. It's an equation with two variables. Usually it's an x and a y variable. And with equations in two variables, then you can start graphing stuff in 2 dimensions with an x and y coordinate. When we were talking about the standard form of a linear equation, we have this linear equation, and this standard form, this is literally the name of the standard form. It looks like this. It's ax plus by equals c, where a, b, and c are usually numbers. A and b are not 0. So, for example, this could be like 3x plus 2y equals 8. That is in standard form of a line. And we're going to be learning quite a bit about different forms of equations before too long. So number 1, example 1 says we want to check a solution in 2 variables. So I want to know, I have 3 different points. Are these points solutions to this equation? Now, just because one point is a solution does not mean the others are not. It's possible to have multiple solutions. So you do have to check every single point, even if you find one of them is true. So let's see. Like all this stuff and just move it up here a little bit. So we're going to take and we're going to plug in our x value for the x variable. So this will be 4 times 1 minus the y goes in for the y. And I want to know, does this math equal 5? So 4 times 1 is 4. Oopsie. And 4 minus 9 is a negative 5. Does that equal 5? No. So that point is not a solution. Okay, second one. 4, and we plug in 1/2 for the x, minus negative 3 for the y. Now notice how I have 2 negatives here. I have the negative from this minus sign here, and this negative 3 is here. You do need them both. When you do this math here, this side, 4 times 1/2, well, half of 4 is 2. And if you remember from integers, when you have a minus a negative, you can change that to plus a positive. So this really means 2 plus 3. And 2 plus 3 is 5. So this one is a solution. But just because this is a solution does not mean it's the only solution. There are many. In fact, there's an infinite number of solutions. So we've got to check this guy as well. So 4 times 4 minus 1 equals 5. Okay, so 4 times 4 is 16. And 16 minus 1 is 15. Does that equal 5? No. So you take your x variable and you plug the x value in. You take the y value and you plug it in for the y variable. X in for x, y in for y, and then do the math and see if you get something that is true. If you get something that's true, like 5 equals 5, then it is a solution. If you get something that's false, like these other two guys, it is not a solution. Please try letter B right now. Pause the video and do the problems. When you're ready, hit play, and we'll continue on. Okay, so let's see. Negative 4 is the x value. 1/2. And 20 is the y value. So half of 20 is 10. And 6 plus negative 4, or negative 4 plus 10, that gives you a positive 6. So yes, that is a solution. So that point is a solution of that equation. Let's see, letter B. 3.5 plus 1/2 of 3 equals 6. Well, half of 3 is 1.5. And 3.5 plus 1.5 is 5. 5 equals 6? No, that is not a solution. Lastly, 0.5 plus 1/2 of that equals 6. So I plugged in x for x, y for y. And we get, well, can't do any math there. So 0.5 plus half of 11 is 5.5, 5.5. And 5.5 plus another half does give us 6. So this is another solution. So 2 of these were solutions. 1 of them was not. I'd like you to do one problem out of the textbook, just practice for the same exact thing. I'd like you to tell me whether this is a solution of that equation. So this is from page 215 of the textbook, number 1. Pause the video, hit play when you're ready to continue. Okay, so we're going to plug the x in for x, y in for y, so this will become 4 plus 2 times a negative 1/2 equals 5. Well, 4 plus 2 times negative 1/2. Well, half of 2 is 1, and the opposite, that would be a negative 1. 4 plus negative 1 is a 3, and 3 equals 5? No. So this point is not a solution to that equation. So that's one thing that's important to be able to do, is figure out if a point is on a line. And that's really what this is asking. All the points that we said yes to, this point, if I would draw this line, this point would be on that line. So if you imagine, I'm just making something up, this point, 1/2 negative 3 would be like right there. It is actually on the line. These other points that we said no to would be off the line. It's extremely important to be able to tell which points are actually on the line. Now, example 2. I gave you one big graph space here, and on the side that goes A, B, C, D, E. We're going to graph all 5 of those on this one graph space. Okay, so don't make everything too sloppy. So first one here is we want to graph this equation here. Now, it gives us some x value. So what we can do here is we could do a couple different things. We could just start plugging in x values for x and solve the equation. Or we could do the opposite of that. We can solve the equation first and then start plugging the x values. Both ways have their merits. The way I find to be easiest is actually to solve for x first, to get the x value, the y variable by itself. So watch this. I'm going to minus 2x minus 2x. What I would get if I subtract 2x here, I get y equals negative 2x plus 2. This equation is going to be easier to plug this information into. So if we plug in a negative 1 for x, let's think about this. Negative 2 times negative 1 is a positive 2. So 2 plus 2 is 4. It's now easy enough we could do the math in our head. We plug in a 0 for x. So negative 2 times 0 is 0. 0 plus 2 is 2. Plug in a 1. Negative 2 times 1 is negative 2. So negative 2 plus 2 is 0. And lastly here, we plug in 2. Negative 2 times positive 2 is a negative 4. And negative 4 plus 2 is negative 2. So now you see we have 4 points. We have the x and y coordinate. We can graph those on our grid space. So I'm going to graph the point negative 1, 4. 1, 2, 3, 4. 0, 2. 0, 2. 1, 0. 2, negative 2. Now you see how this makes a nice straight line. We want to continue this straight line. So got arrowheads here, good. Now I'll make mine small and then I'm going to make it bigger. It's a little bit easier to make the line straight this way. We want this straight line to extend a whole way if you can. So use a ruler or the edge of a textbook or something to make your nice straight line. And we'll even label this one as from function. This is our graph of A. So this is function A. So we solved the equation for y. We got the y variable by itself first. Then we plugged in our x values in for x, did some math, and found our y values. I'm going to erase this to do letter B. There's also some space underneath of the graph on your note sheet. That's a good place for you to do some work too. So letter B. To get this by itself, so it says negative 2x plus 2y equals negative 6. We're going to add 2x. We get 2y equals 2x minus 6. Divide by 2. Divide by 2. These cancel. Y equals 1x minus 3, because negative 6 divided by 2 is a minus 3. Okay, so now we have this. If you can get that, it's going to make the rest of your problem quite a bit easier. So now we plug in negative 1 for x. So 1 times negative 1 is negative 1. Negative 1 minus 3 is negative 4. That's just integer math. Plug in 0 for x. 1 times 0 is 0. 0 minus 3 is minus 3. 1 times 1 is 1. 1 minus 3 is negative 2. Plug in 2. 1 times 2 is 2. 2 minus 3 is negative 1. By the way, the reason why we have the numbers negative 1, 0, 1, and 2, these are actually numbers that I just kind of came up with. The original problem will probably just say, graph the equation, and it'll give you this. The reason why we choose the numbers negative 1, 0, 1, and 2 is those numbers are close to 0. They're small, which makes doing this math much easier. Imagine we pick the numbers 19, 47, 36, and 87. I mean, it's going to be very hard to do those numbers in your head, but I can plug in 0 in my head and do that math. I can plug in 1 in my head and do that math. I can plug in 2 and do that math. So we chose small numbers around 0 because they're easy to do the math with. That's why. So let's graph this now. We have our 4 xy pairs, our 4 points. We're going to graph them here someplace. So let's see. Number goes negative 1, negative 4. 0, negative 3. 0, negative 3. 1, negative 2. Sideways 1, up and down to negative 2. And lastly, 2, negative 1. Sideways to 2, down to negative 1. So we see the line. Change this thing again. And now I'm extending the line both directions all the way. This is this function. Now, we do have arrowheads on both ends of our line because this line technically does go forever. We are only graphing in the space we see here, but it does go on forever and ever and ever and ever and ever, forever that way and that way. Okay? Letter C. I'm actually going to do letter C with you instead of having you do it on your own, because this one's a little bit different. Here it says y equals 3. Now you notice I don't have any other values in here. Now, this is kind of a trick question, sort of. First off, let's come up with some x values. So why not use these same guys again? Negative 1, 0, 1, and 2. It makes no difference. You could pick negative 2, 3, 4, 5, 6. I don't care. Now, you're looking for a place. Where can I plug this into there? Well, you can't. There's no x variable in that equation. Well, the trick here is you actually don't need to plug them in. Read the equation. It says y is 3. That means no matter what the x value is, the y value is 3. The y value is 3. Is 3 is 3. So this is actually going to be a line where all the y values are 3. Y equals 3. So let's find this first one. We're going negative 1, 1, 2, 3. 0, 3. 1, 3. 2, 3. We've got ourselves a horizontal line right at the value y equals 3, right there. By the way, we labeled A. This guy was B. This guy is C. So when you have something like y equals 3, that means all the y values are 3, and you can make up whatever you want for the x values, and it'll still work. You're going to see later on one where it says like x equals something. Well, that means that all the x values are that thing, and you make up your own y values. Okay, so we've done these 3. I would like you to try these next 2. I recommend you solve for y first, then come up with some values for x, plug them in, do the math, get the answer, and then graph. Go ahead, copy them down, pause the video, do them on your own, and then hit play only when you want to check your work or when you're done and we can go over them together. Okay, now on my board here I have a new graph space. You keep graphing on the same one where you have those other 3 lines going on there. Okay, so first things first, I'm going to solve this for y. So there's no parentheses, no like terms, no variable on both sides. Get rid of the add and subtract. So I'm going to minus 4x. And I get negative y equals a negative 4x. To get rid of this negative 1, we divide by negative 1, and we get y equals positive 4x. Negative 4 divided by negative 1 is positive 4. Alright, so this is the one I'm going to be using when I plug my numbers in. Now, what numbers do I want to choose? I don't care. Pick them. I'd pick things around 0. Maybe just to change it up, we'll do negative 2, negative 1, 0, 1. I don't care. Or you do negative 1, 0, 1, 2. It makes no difference. I like numbers around 0, and I like having a couple negatives and a couple positives. So let's plug them in. Negative 2 in for x. So we take 4 times negative 2 is negative 8. Negative 1 in for x. 4 times the negative 1 is negative 4. 4 times 0 is 0, and 4 times 1 is 4. That was pretty easy. Let's see, we graph it. Go x to negative 2, y to negative 8. x to negative 1, y to negative 4. X to 0, y to 0. X to 1, y to 4. So you have a nice straight line. Let's go ahead and graph it. Again, use like the side of a paper or a textbook or a ruler to make your line nice and pretty and straight like mine. And there's that equation. The last one here is kind of like one of those tricky ones I told you about where we have the x value is always negative 7. So hopefully what you did is you start by putting negative 7, negative 7, negative 7, negative 7. X is negative 7. Boom. Now the y value, you can choose whatever you want. It does not have a y value, so you can say, okay, fine, maybe that's the negative 2 and the 0 and 1 and 4, or whatever you want to do. And now let's graph it. So x of negative 7, y of negative 2. X of negative 7, y is 0. X is negative 7, y is 1. X of negative 7, y is 4. Those are these 4 points. You see the line it makes, don't you? It's a straight up and down line going through x equals negative 7. And this was letter D, this was letter E. So that is how you graph an equation. This is called graphing using an XY table. This XY table will always work. There is never a time this XY table will not work for you. It will always work. Now, it won't always give you pretty numbers, but it will always work. There are some other methods you're eventually going to learn that do not always work. So, try these 3 problems out of the textbook. This comes from page 217, numbers 2 through 4. Go ahead and graph these. There's space on your note sheet for you to graph. And then pause the video when you're ready to continue, hit play, and we'll go over them together. Okay, number 2. First things first, I want to get this y by itself. So I'm going to subtract 3x. And I'm going to get y equals negative 3x minus 2. Now, I don't have an xy table, so you make one. Oh my goodness, that was hard to do. It's easy. You just make an xy table. Now, come up with your own x values. We don't have x values yet. It doesn't give us x values, so use the ones I recommend. One's around 0, negative 2, negative 1, 0, 1, 2. There's a whole bunch of them. So now you plug them in. You plug the x value in for x, you do the math, and see what you get for an answer. So negative 3 times negative 2, I'll do the first one, I'll write it out. Negative 3 times negative 2 minus 2. So negative 3 times negative 2 is a positive 6, minus 2 is 4. Then we plug in negative 1 for the x value. Negative 3 times negative 1 is a positive 3 minus 2. 3 minus 2 is 1. Then we're going to plug in a 0. So negative 3 times 0 is 0. 0 minus 2 is negative 2. Plug in a 1. Negative 3 minus 2 is negative 5. And finally plug in a 2. Negative 3 times 2 is negative 6. Negative 6 minus 2 is negative 8. So now we have some points. We plot them. First one goes sideways to negative 2, up to positive 4. 2, 3, 4. Second one goes sideways to negative 1, up to 1. Third one, sideways to 0, which means you don't move at all, down to negative 2. Third one, sideways to positive 1, down to negative 5. And actually, this last one doesn't fit. We'd have to go down to negative 8, down here someplace. So now we graph our line. My line is not very good. That's better. That is our line of this function. Number 3, XY table. Now, let's we don't have to solve this. The y is already by itself. And so we pick some numbers, -2, -1, 0, 1, 2. It says y is 2.5. No matter what we plug in for x, the y value is 2.5. So 2.5, 2.5, 2.5, 2.5, 2.5. So when I go sideways to -2, up to 2.5, which, by the way, is between 2 and 3. Second point, sideways to -1, up to positive 2.5. Third point, sideways to 0, up to 2.5. Fourth, sideways to positive 1, up to 2.5. Sideways to positive 2, up to 2.5. You see the line, right? It's this flat line going straight across here at 2.5. Lastly, number 4, I'll do my work down here. So x, y, x is -4. That means we can't even make up our own x values. It is telling us x is -4. But it does not give us any clue about what the y is, so we can make these guys up. 1, 0, -1, -2. Why not? So you go sideways to -4, up to 1. Sideways to -4, 0. -4, -1. -4, -2. You see the line? Straight up and down at the x value of, there. Straight up and down at the x value of -4. So those are the lines that we're graphing. Okay. Now we're going to graph a linear equation, which, by the way, we've done a whole bunch of times now. So we're going to graph this function. It's going to give us a domain, and then we have to find the range. So the first thing we need to do is we need to make ourselves our nice xy table. I like to use those same numbers, so -2, -1, 0, 1, 2. I like numbers around 0 because it makes it easy to do the math with. Oopsie, but I guess I'm not paying attention. It says with a domain of x values bigger than 0, which means these guys, I can't even do them. I'm not allowed to have things less than 0. So it has to be 0 and bigger. Okay. So now we're going to take this function. We're going to plug in 0 for x. So y equals -1/2, 0 plus 4. Well, 1/2 times 0 is 0. 0 plus 4 is 4. Now we're going to plug in 1. -1/2 times 1 is -1/2. -1/2 plus 4 is 3.5. Plug in 2. -1/2 of 2 is -1. -1 plus 4 is 3. So we have 3 points. That's enough to graph our line. You should have at least 3. So we have, go from 0, 4, 1, 2, 3, 4. 1, 3.5, over 1, up 2, up 3, up a half. 2, 3, up over 2, 1, 2, 3. Now, when you're graphing, your points should make a nice straight line, and mine do. You see they make a nice straight line here. Now, I'm going to draw my line and extend it up the other way for a little bit. Now, we're going to modify this because this is not quite correct. So that is this line, this function. Y equals -1/2 x plus 4. But what we did not do when we graphed this here is we did not pay attention to this again. On purpose this time, but we didn't pay attention to this. It says x is bigger than or equal to 0, which means you're not allowed to have any values that have an x value less than 0. So anything on this side over here is not allowed. So my line can't be over here. It actually has to start there, when the x value equals 0. But it can still extend this way forever and ever and ever and ever and ever and ever and ever. It keeps going. Even past our little grid space, it keeps going. Okay? Now the question asks us, well, first off, graph the function. We did. Yay! Check. Second step, identify the range. So the domain is the x values. The range are the y values. So you got to ask yourself, what y values, what up and down, is this line eventually going to go through? Now imagine it goes on forever this way. So is this line going to go through a y value of, say, -10? The answer is yes, it would. If I would continue this line forever and ever and ever, look, I'm already at -1, -2, -3, -4, -5, -6, the whole way down, it will eventually go through -10. So -10 is part of the range. Will the line go through a -100? Yeah, if it keeps going down, why not? Okay, what about going the other way? Will this line go through +10? No, it won't. Because this line starts here and goes down. It's not any higher. So this is actually kind of like the place where the range starts. It goes from +1, 2, 3, has a range of 4 or less. 4, it goes 3, 2s, 1s, 0s, negatives. So the range is the y values are less than or equal to 4, because this is where the line starts. It does not go above this. There's no y values of 5 or 6 or 7 or 8 or 9. The y value starts at 4 and goes down. So the y values are less than or equal to 4. That is the range. Domain are x values, range is y values. Now, that's example A. Here's example B. Try this first. What I'd like you to do is first start by just making the XY table, and then hit play in the video again, let it catch up, and then I'm going to have you go step by step. So first off, make your XY table and fill it out. Hit play when you're ready. Okay, so XY table. X, Y. -2, -1, 0, 1, 2. Again, we're just picking those numbers at random, but numbers close to 0 because it's just easy to do the math with. If you use this function -x plus 2, now I guess we should check these x values. Now we can only use values between, it says greater than -3 and less than 2. So these are all good values. Okay. And actually, we're going to need another value in here. We're going to need the value -3. Anytime they give us a range like this, you should always use these two numbers as part of your graph, so you at least know where it starts and stops. So I'm going to put in -3 there. So now let's plug in our x values and our y values. So y equals, plug in -2. So -2 is a +2. 2 plus 2 is 4. -1 is a +1. 1 plus 2 is 3. 0, we plug a 0 in here. 0 plus 2 is 2. Kind of see the pattern. -1 plus 2 would be 1. -2 plus 2 would be 0. Now, we need this other guy because we need to know the starting and stopping points of this function. So that's why we're using the two endpoints, -3 and 2. So if I plug in -3, a -3 is +3. +3 plus 2 is 5. Alright, so now let's graph. I'm going to graph him first. We got -3, +5. 1, 2, 3, 4, 5. -2, 4. -2, 4. -1, 3, 0, 2, 1, 1, 2, 0. That's all these points graphed right there. Now, it says that our x values cannot be less than 3. So when we're talking about our line that's going to go through this stuff, there's our line. Our line cannot go over farther. It cannot go past the x value of -3. So it cannot extend farther. It actually starts right there. And our x values cannot be, excuse me, they have to be less than 2. They cannot be bigger than 2. So my line does not extend this way. It actually stops right there. It cannot go past this line of x value of 2. So it goes from there to there, and I can change the endpoint there. So that is the function. It does not go on forever. It's just from here to here. That's kind of like its border lines, right there and there. X value is bigger than -3 and smaller than 2. Bigger than -3, smaller than 2. So the range would be what? See if you can identify the range. Pause the video, hit play when you're ready to check over together. Okay, so the domain blocks it off left and right. So now we just got to see where is it in the up and down area, because that's the range. Range is the y value, so it does not go above there, does not go below there. So the range is going from here. Ooh, that was terrible. Let me try that line again. The range goes from here to there. So range goes from a positive 1, 2, 3, 4. Range goes from positive 5, so the y values are less than or equal to 5, and it goes till 0. Y values are bigger than or equal to 0. You can write it like this as two separate inequalities. The y values are less than 5 and bigger than 0. That is the range. So anything in that area is allowed. Anything outside of that area is not allowed. Okay. There is one problem for you to try out of the textbook. Page 217, number 5. There it is, and I gave you some graph space to do it. Please try that problem. Pause the video. Do it on your own. Hit play when you're ready to continue. Okay. XY tables, the way to do it. It works every single time. Now it says here the domain is bigger than 0. So I just need numbers 0 and bigger. Make sure you use that as your point, one of your points. So now I just need to do 0 and then big, or I'm sorry, x is, yeah, I can read, less than 0. So there's my 0. Still, 0 is allowed to be used. Now I need values less than that. So -1, -2, -3 should be fine. There. I'm just setting up my work that's going to be happening here. So if I plug in 0, -3 times 0 is 0. 0 plus 1 is 1. Now I plug in -1 for x. -3 times -1 is a positive 3. 3 plus 1 is 4. Plug in -2. -3 times -2 is a positive 6, plus 1 is 7. And -3 times -3 is a positive 9, plus 1 is 10. Now, we're not going to be able to fit all that on here, but we should be able to, the absolute minimum number of points to graph a line is 2. 2 points make a line, 3 points is better, 4 points is even better. But if we have 2, that's okay. So let's graph these points now. 0, 1, 0, 1. -1, 4. 1, 2, 3, 4. -2, 7. 1, 2, 3, 4, 5. We could imagine 6, 7. Something like that. You see how the line goes this way? Now, when we graph our line, it says that the domain, the x values, the sideways values, have to be less than 0. So I cannot go this way. I have to stay on that side of the line. So look what happens to our y values. Our y values can keep going up, 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 because they're going this way. But they stop right there. I'm getting a little funky with my lines here. The y values actually stop right there because they cannot go below this point. So my range, identify the range of the function. The range of the function are what are the y values? Well, these y values can be anything big, 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 until you get down to 1. They're not allowed to be anything less than 1. So think about that. My y values have to be bigger than or equal to 1. That would cover every one of these y values. 3 would work, 5 would work, 10 would work, 1,000 would work, 1,000,000 would work. 0 would not. -1 would not, because we're not allowed to be down here. Okay? Now, the last thing in this problem is just kind of an application, multi-step problem. It says here, the distance a runner runs is given by the function d equals 6t, where d is the distance and t is the time in hours. Okay. The runner plans to go on a 1.5 hour run, so we can add some words in there, on a 1.5 hour run. Graph the function and identify its domain and range. Okay, so we want to graph this function and identify its domain and range. So, first off, xy table. That's how we graph a function. This is our function. Now, think about how we had it before. We always had y equals. This is our y, this is our x. Now, if the planet plans to go on a 1.5 hour run, what times would you expect to see? Well, the guy could be running for 10 minutes. He could be running for 20, 30, 40, 50, 60. He could be running up to an hour and a half. You would not expect him to be running for 2 hours. So we're going to call the domain, the time, the domain would be x values less than or equal to 1.5. Because if he's going for a 1.5 hour run, his time could be 1.5 hours or less. He's not going to be running more than that, but he could be running for less than that. And then we're going to find the range after that. So we want values less than 1.5. But you also have to think. This is kind of a real life problem. Is it possible for this guy to be running for like -1 hour, -2 hours? That wouldn't make sense. So we could say the domain is less than 1.5 but bigger than 0. Because he can't be running for less than 0 hours. He's just kind of sitting there. So that's about our domain. So he's going to be running someplace between 0 hours and 1.5 hours. We do not yet know the distance he's going to travel, though. So we have domain. So now we know we can pick any numbers from 0 to 1.5. So 0, 0.5, 1, 1.5. Again, make sure you use the domain values as your endpoints. 0 and 1.5. Now, if we do this math, actually, I could probably do it over here. D equals 6t. So 6 times 0 is 0. So this guy's been running for 0 hours. He has a distance of 0. Makes sense. He's still on his front porch. He hasn't left his house yet. Okay. Now, what if the guy's running for 0.5? For half an hour? Well, 6 times 0.5 is 3. So if he runs for half an hour, he's gone 3 miles. Keep going. What if he runs for 1 hour? Well, 6 times 1 is, he's at 6 miles. And finally, if he goes for 1.5 hours, 6 times 1.5 is 9. Okay, let's graph this beast out. We got 0, 0. I guess we should have a scale here someplace. We've got our time. We've got distance. And this scale, since we're going up to 9, We can count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since here we're only going up to 1.5, it wouldn't be very smart to go 0, 1, 1.5. It would look very bad to have all of our points in this little area right here. So let's just kind of space this thing out. What if we go 0, 0.5? So I'm skipping a space, 0.5. Skip a space, 1. Skip a space, 1.5. Skip a space, 2. Now we're not going to get to 2, but we can still have it part of our thingy, our scale. All right, so now we graph 0, 0, got it. 0.5, 3. 1, 6. 1.5, 9. First off, you'll notice it's a nice straight line. That means it's a linear function. Now, we said that the time has to be bigger than this and less than this. So now what would be the values of the range? The range is the up and down. In this case, it's the distance he's going to travel. He can travel a range of what? Well, from here to here, we would get a range of 0 up to 9. So we can say our range, our y values are bigger than or equal to 0, and our y values are less than or equal to 9. Now I have this written as two different inequalities. I'm going to show you something slightly new here. This is called a compound inequality. So we can say this y value is bigger than or equal to 0, less than or equal to 9. Basically, it's this same thing, but written as one inequality. These are exactly the same. This is a little bit neater because it's less writing to do. Okay? So we made an XY table. We found our domain from reading the problem, kind of using our brains. So if the guy goes for a 1.5 hour run, he could be running anywhere from 0 hours to 1.5 hours. Those were the values we picked when we came up with our x values. We plugged them into our function to find our y values. We graphed those points. And then we found our range based off of our line and where our data was. Okay. I would like you to try example 4, letter B. I think this is the last problem for the day, so try this problem out, pause the video, work on your own. When you're ready to continue, hit play, and we will go through it together and get it done. Okay, so we've got ourselves our function. That is our function, where y and x, again, x is kind of the independent variable, the number of pages is the dependent, so x, y. Got ourselves our little table here. Student plans for type. The student plans to type for at most 2.5 hours. So if we're talking about our domain here, he's going to be typing anywhere from not at all, so 0, until possibly 2.5 hours. So x is less than 2.5. He's not going to be typing for more than 2.5. It says he plans to type for at most 2.5, so less than that. But x is also going to be bigger than 0 because you can't have less than 0 typing. You can't type for less than 0 hours. You can't have negative hours. So make sure you use these two values when you're making your XY table. So 0, 2.5, and then pick some numbers in between. How about 0.5, 1, and 2? Why not? You need a couple points. That'll work. So now let's plug in some numbers. Our function was p equals 4t. P is the y times 4. T is the x. So let's see, if we plug in 0, let's just play pretend for a second. We plug in 0, 4 times 0 is 0. Okay. If we plug in 1/2, 4 times 1/2, well, half of 4 is 2. If we plug in 1, 4 times 1 is 4. If we plug in 2, 4 times 2 is 8. And if we plug in 2.5, 4 times 2.5 is 10, I believe. 2 times 4 is 8. Half of 4 is 2, 8 and 2 is 10. So now we graph this. We got point 0, 0 is there. We need a scale of some sort. Well, this is going up to 10, so I like counting by ones. 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going up to 2.5. Let's just plan it out. 0, 1.5, or 0, 0.51, 1.52, 2.5. I think that's probably best. 1, 1.52, 2.5, and then be 3, 3.54, but we're not going to need any of the guys over there. Okay, so we got 0, 0. That's always the origin. 0.5, 2, 1, 4, 2, 8. Notice we skipped 1.5. 2.5, 10. They do make a nice, pretty straight line. It says our domain goes from 0 to 2.5, so it has to be bigger than that and less than that. So it's only trapped in this range. Well, if we draw our line in here, what are the y values this line is going to go through? Well, it's going to go from 0, so range. The y values are going to be bigger than or equal to 0, see? And less than or equal to what? Well, the biggest y value you're going to get is 10, because this line can't extend farther, so this is the top it's going to go to, less than 10. Okay. So in summary, how do you graph an equation in two variables? If you could, please write down a little summary sentence or two kind of describing what you learned today. How do you graph an equation in two variables? Hopefully you said something like, first, solve for y. That's when we got the y variable by itself. Then make an xy table actually be like this, x/y table. Make an xy table, plug in x values, then evaluate to find y values. So first you solve for y. That's when we got the y variable by itself. Then we made an xy table, and we plugged in some x values into the equation, and then found out what those y values were, then plot the points. Okay, and there is the homework. It comes from page 219, numbers 2 through 12, 21 through 25, and 38. Go ahead and copy it down, and I will see you next lesson. Bye-bye.